Okay, sorry about that. I made a note last time to dump my bitrate, decrease my bitrate, as I've been running into latency issues with the stream, but we rocking now. We rocking it now. Average stream bitrate too high. Yeah, stable. What do you mean? Oh no, it's because I just turned that down. That's why it's down. Okay. Jesus. What's up? What's up? What's up? All right, dudes.
Voices, words, dream, memory, revolution, salvation, music, and distance.
All right, dudes. Welcome back to the freaking broadcast. Welcome back to the freaking broadcast.
Destiny.
Okay, bitches. This is what we got today. We got a blank KiCad project that we're going to turn into a controller for our air intake module. Got a nice little vein right there now. LOL. Alright, so last time
Voices.
we got pretty much all the way through
History.
the software.
Transform.
I mean, we definitely proved
Dream.
the concept
Stars.
for definitely proved the concept for being able to do everything that we want with the BeagleBone. We can do ADC stuff, no problem. We could do the PWM very easily. Got Linux, so I mean, in terms of stuff left to do on the software side, there's some polish, but and obviously then the whole project of like actually making a UI that looks good or that maybe interacts with Home Assistant, which I don't have set up. I mentioned that in the contact video that I was interested in plugging it in with Home Assistant, but I don't have Home Assistant set up. So I mean, from my perspective, the hard part was just proving out the like web API, REST API to like PWM and then to read the temperature parts, which is done. And so now we have the project of the electrical stuff, which I think is going to be very easy. Originally, too, I also wanted to use those DC to DC converter modules to control the fans. I don't think I'm going to do this. I think I'm just going to use MOSFETs because I'm not totally sure about the PWM or the DC to DC converter modules. Those aren't like totally ready for. I mean, I'm like that design is like another project I'm working on that I'm not totally happy with yet. So I think it probably doesn't make sense to put that into something that's gonna live for a long time. Like, but you know, maybe we could do V2. eventually with that. So I think we can start. Let's go to DigiKey. So this 30N06L single MOSFETs. Yep. N channel power MOSFET. This guy too. Never got hit with that before. So I think the first thing to do is pick a MOSFET. I don't have... Actually, let me check. Let me switch over. Keep... Yeah, data sheets. That's resistors. Keep my parts in a binder. What? Is this camera working? It is. These are all my surface mount parts. I don't think I'm gonna have what I want. Inductors, DC to DC. What is this? There's a regulator. Yeah. I don't have it. Ooh, shock key. No. Yeah. Honestly, kind of recovering from a component disaster recently, so I really do not have a ton of parts. But it's fine to order some new stuff. So I guess we gotta figure. Let me go back here. All right, so I guess the one thing here is the VGS. We want this to be, I think the, I don't think it's 3.3 volts. I think it's less. 8 PWM pins, internal PWM pin. Grounding, do not connect to, this can damage the board. Voltage. Square wedge, altitude, voltage. The output square weight voltage is a 3.3 maximum and 0 volt minimums. Okay, so this is fine. So let's just hit a bunch of these. What is the fucking problem here? So I'm looking at this number, this count. $18. What? There's only 8? I'm trying to pick out a MOSFET here. Huh. This doesn't make any sense. In stock, normally stocking. Starting from scratch. Oh my god, DigiKey being slow, bro. Okay, so rate, drive voltage, drain to source voltage. So let's say 30 volts max. And let me pull that, actually, let me get this data sheet back up. This is 60. Oh no, I wanted to do minimum of 60. Is it the VM that's slow or the website that's slow? It's the websites that's slow, of course. 30 minimum. Okay, this is too slow. I'm gonna switch to my other Firefox. It's being really slow in there. Wait, is it just... I don't really want to do that. Is it me? Kind of getting owned. Okay. Drain current 30 amps. That is probably more than we need. It's a little tiny fan, but let's do 5 amps and up. Yeah, these packages are still pretty small. Yeah, 67 cents. Yes, sir. Wow, look at that fucking package. Yikes. Yeah, this is what I want right here. Something like this. Something small. SO223. Alpha Moss. That's what we're gonna do. Can I do power dissipation max? Power dissipation 79 watts. Wow. Anything in a small package that can do this much? $2 per. Yeah, it's the same package. Yeah, it's a little overkill. A little overkill. So, what is the fan called again? It's all numbers. This is our fan. Yeah. 3 watts. So call it 15 watts. It has to dissipate. So let's say this actually is. So what did I say before? Power dissipation. I don't want power dissipation max. Is there power dissipation continuous? Continuous drain current. So it's like a little over an amp. So that's what the issue is. Anything greater than 1 amp. There's 2.5 watts, so like 10 watts per MOSFET. Power dissipation, 10 watts. What is TC versus TA again? It's case versus ambient. Case temperature. Mm-hmm. Price low to high, bitch. Next vet. This thing is gonna be so annoying to solder though. This would be so much easier to solder. The Brit Wilder. The bit wielder. Whoop, my bad. Yo, what's up? I'm building an air intake system for a server rack. And we're now at the PCB design stage, and I'm doing some online shopping in time for Christmas. Cool, yeah. Wait, let me show you the CAD. So I've been ripping on this for 5 Tuesdays. This is the rack. And it's kind of hard to see everything. I have these giant models for the computers. Oh wait, this is the front. I'm gonna hide these. You. Be gone. So I have this server rack, and it has a beautiful glass front door and a back. But the issue is when you close it, there's no air intake because these vents don't have fans in them. So I found, let me show you this. I found this rack on the street. Let me pull this up. Somebody threw it away. And so I've been, this is my blog. Where is this post? Yes. Yeah, here it is. Yeah, so I found this rack. I threw it in the little truck, got it home, and I've been working on it and getting my home lab set up in it for a while now. This blog post was in August. I found the rack like over a year ago now. But cleaned it all up, got everything installed, stuff's looking good. And I've been working on doing air intake. So doing getting air in through these vents on the side into the server, so I can close it all up and it can be super clean and neat and nice. And so that's what I'm working on here. That's what I'm working on here. So we've got, let me show you this too. So we got most of it built, or we got mechanically a lot of it built. We got BeagleBone Black, which is gonna be the brains of the whole thing, and we're doing just MOSFET control of the 3 fans. There's gonna be 4 modules, like 1 for each of the 4 vents, but they're all gonna be controlled by the BeagleBone, and so a bunch of them are gonna be just like kind of dummy loads, just like the 3 fans wired in parallel, and then this everything connected together. And then we got temperature feedback, which I haven't got the thermistor resistance to temperature working, but haven't really written any of the software. Or that's not true. Written a lot of the software, but no like feedback stuff yet. Just like an API to get it working. Yeah, and I'm looking for MOSFETs. Yeah, I have the ones that I was using on the bench, but yeah, I'm looking for some through-hole pieces, or some surface mount. Sorry, yeah, some surface mount pieces. Ragel DSO 1054Z. I think so. Yeah, 1054Z. That's the one. The Classico. The Classico. Yeah. Yeah, looking for FETs now. I'm trying to see what is the footprint of this. This one is really cheap. Six WDFN exposed pad. Do we think KiCad ships with this? What do we think? So we got place, add symbol, and MOS. Oof. international rectifier to be a very reliable source of all those. Yeah. Dude, this is, but I believe it. I'm also literally just making one of these. So I'm not too... let's try Googling it. Sometimes it's easier to... DFN, QFN. So it looks like it's in there. Yep. Two exposed pad. Oh my god. Yeah. I've used IRF 1010 for PWM signals and control, and they've always been pretty damn reliable. Yeah. IRF 1010, let's go look at that. N10E. Oh, crap. Yeah, this is good. I'm honestly like more tempted to go with something like this just so it's got the footprint. What did my search have before? Yeah, I kind of do not want to draw a footprint into KiCad for this. They also have an SMD variant. Yeah, that's what I'm seeing here. This guy. $75 amp. Yeah, damn. What is the VGS? Yeah, I need less. I think I need a smaller VGS because I'm using the BeagleBone, which has 3.3 volt logic. These 5 volts in work relatively nicely. Yeah, I don't think I can use this because I have to use 3.3 volt logic. Also pretty powerful. Damn, this is awesome though. Yeah, put my search here. Damn. Of course, the very annoying packages are the cheaper ones. I think we're just gonna go with this guy. Strip FET. Yeah. What is this footprint? Type surface Mac power pack. SCO6 power pack SCO6. What do we think? Do they have it in KiCad? KiCad. SC76. That looks... SC76. Wait a minute. What was the name of the library? Crap. My memory is failing. Oh, this is in Tinkerforge. Package SOT TOSOT SMD. TOSOT SMD. SOT SMD. Ah! Ooh, and there's a hand soldering variant. You could just use a common op amp to boost it. You could. You could. 100%. Whoops. I think that is fast enough. There's a few extra wiggle room when it comes to power demands. Yeah, 100%. And the thing is here, I don't think, so these guys have power dissipation of 13.6 watts. So each of the fans consumes 2.5 watts. So we have like a factor of safety of 2, because like there's 3 fans per module, so that's like 9. It's a little less than 2, but it's definitely, there's definitely a safety factor. And these are tiny as hell, which is kind of nice. Let me get on my PC and look through the data sheets. I love it. Wait, this is not gonna work. Why is my BGS max? Oh, I just broke at my search. BGS. Just look at the MOSFETs you have. Nice. max RDS on, min RDS on. Can't remember the specs, but look for an IRF 3205. Let's take a look, bro. There is VGSTH. Yeah, it's 4 volt VGSTH again. Sadly. And I kind of don't want to be messing around with op amps, so this is can be a pretty simple circuit, so I think we should try to aim for that. What about CDS? I'm looking at my notes over here. Yeah, this is the one we just looked at. Okay. This one. IRL. Let me look at this. IRL Z44N. While not very efficient 3.5 feet, so it does work moderately well. Nice. Two volts. Nice. Not very efficient at 3.3 volts. It does work moderately. Damn. Okay, this is the winner so far. This is the winner so far. Damn. Continuous drain, 47 amps. That's worth a gong. 47 amps is worth a gong. Where's my soundboard at? $47 amps of pure power, dude. International rectifiers rule. Damn, this data sheet is hard. This font is sick. Alright, I'm pinning this tab. Pin tab, dude. It is a little bit expensive. It is $2 a pop. But I only need 4 of them. I do kind of like these fucked up little footprints though. I lost my search. No. Okay, I'm gonna clear some tabs out. Hey, it's one reliable damn MOSFET. Yes. What is happening? Why is it? Alright, so we're gonna do N channel, in stock, normally stocking. DigiKey is being slow tonight, bro. Something like 47 amps continuous drain. Yes, I saw that. That's insane. Is it me or DigiKey that's being slow? It's probably me. I have a ton of stuff open. Okay, nice. There we go. All right. Do the SMD version. It's more like 5 amps without cooling. Yeah, I'm not gonna do. Don't want to do cooling. Just gonna do. Hopefully, like exposed pad to the some sort of just big copper polygon on the board. Hopefully. It is going to be right in some nice air. Yeah, it's plenty for some fans. Yep, I agree. That's a good first candidate. I am going to do a little bit more looking though. Power dissipation. Let's do. Let's do anything above 12.5 watts. What's the power draw? It is 2.52 watts. Let me pull it up. I have the data sheet open, but I closed it. I gotta go grab the part. Whoop! I gotta grab the part number. Hilariously, off the fan. Off the name of the cat. Part in CAD. .21 amps. So, I mean, your part's good, right? But I'm just checking out the other stuff out there. And there's 3 of them per module. Let me link you to. This is the phone. Look at this print. Okay, wait, what do we have here? Good arc semiconductor. I have never heard of good arc semiconductor. Ooh, nice. What the? Jesus. Is good arc semiconductor legit? They passed the DigiKey test. I know, good old. It's listen. This is worth $1 million in marketing budget to get this kind of a forum post for your semiconductor company. All right, this thing is interesting. What do we got here? Continuous drain, 80 amps. Crazy. TO252. Mm-hmm. This is kind of similar to the one I have in the breadboard right now. FFM. Let me check this one out. Okay, wait. I want to... This is my search. This is the one I'm looking at. Here's the fan. I'm going to pin this tab. What is the switching frequency? Transition frequency. I'm gonna be driving with PWM, so I'm I've just always used MOSFETs for that kind of thing. I ain't driving them at 100 megahertz. I know. That'd be awesome, though. Collector current. Yeah, this isn't enough because it's going to be... Oh, no. Is it? Power max. Yeah. 650 milliwatts is not enough. Yeah, although other parts have had much bigger thermal mass. Because I'm driving three fans per module. So each FET is going to have to drive 3. me add a search. Infineon. Let me look. Let me try this search I got going with the brand you like. You should do 2 amp. Optimus. Here we go. 50 cents. Hmm. Let me sort by, I think I'm liking the SO and TOs. Yeah. Just in terms of hand soldering these. Why is it's funny. I guess it's assuming a huge voltage if you can do 10 watts at that low of a current. Oh, why is it clear? A lot of these good arc parts. Let's look at this. GSFL 2004. Okay, this is my favorite so far. I'm writing this one down. Let's make sure this switching frequency is okay. Actually don't really know what spec I'm looking at for that. I guess the important thing is I think I will continue to look at this off stream, but we can definitely do this with a SOT223 part. So we can start. I think we can just say we're going to use a GDS SOT223 part. I like the fact that the tab there yeah, let's put a pin in that, or let's just say this is our guy. I'm more excited about the footprint. SOT 223. Look, they're already labeled GDS. I mean, also a 2N3055 could do it. It's true. I have a bunch of through-hole versions of that part, I think. Okay, here we go. This is our part. So let me save this. Let's go to skip the PCB editor. Update PCB. There's our part. Okay. Okay. So now we have the challenge of getting the BeagleBone cape format. I think I looked at this. Yes. Template BeagleBone cap. Whoops. Trying to create my own. Pocket Beagle cape template. Huh. BeagleBone Black Cape. Where do I... Is that not in... Add symbol. It's the pocket beagle. Hmm. MCU. I gotta sit up straight. Oof. Why are you even using a SBC? Because I have one. Because I have one that is gathering dust. I have one that is gathering dust. That is languishing. It's been sitting in a drawer for a long time. Yes. And it's so, your ESP so desperately wants to be used. It's sitting there crying out, "Bit wielder, put me in something. Give me something to do." That's what my BeagleBone is telling me. Give me something to do. I have so many capabilities. That's what my BeagleBone was doing. Okay, what is this? Why is this archived? This is an orphan repo. KiCad official libraries. The official KiCad libraries are now featured on the KiCad website. Proving the... Ooh, KiCad libraries are now available for download. It's been sitting on the table. Just please use for something. Yeah, you want to see my... Look at... I have... Let me show you my version of that. I'm gonna go at my drawer of unused MCUs. I got it all. I got it all. We got ancient Arduinos. Look at these, dude. Oh, that one's falling apart. We got STM32's development board. This was actually one of the first dev boards you could get to run MicroPython that wasn't the Pi board, like way back in the early MicroPython days. I got the Classico. This is from college. MSP 430. Come on, man. This is the classic. This is the classic. We did a bunch of labs with this back in school. Abmega 328P. Also the king. The classic. Got this, which I never used. I was gifted this by a client, and I never used it. This is like a kind of ESP32-ish board. Yeah, I think these guys ended up making like a Game Boy thing eventually. Never used that. Wouldn't even honestly know where to begin there. Got... We got a Nordic Semiconductor PCA 10036, which has Arduino headers. We got a Google Coral dev board, which has the Raspberry Pi footprint. I'm definitely going to use this in something. I don't know what, though. That would actually might have been... No, I don't need a Google Coral for a fan controller. And then we got the Raspberry Pis. We got a 2011 launch Raspberry Pi, which I actually still use this board all the time. We got a Raspberry Pi 3, and we got an original Raspberry Pi 0. That is my... That's my chamber of... So, the BeagleBone was in this bin and was like, let me out! So he's getting used. He's getting used. Damn, the Google Coral. Yeah, Google Coral, that was another gift. Or I guess work, research present? I don't know. Okay. KiCad GitLab page. Okay, so that's why I can't find any of this. Because it's on GitLab. KiCad footprint. KiCad symbols. One is an Arduino Uno R3 and the other is a Nano knockout with an FTDI external programmer and the ESP32. Aside from those boards, I only have the Ground Studio boards. What's the Ground Studio? Oh, nice. These are... Marble Pico. Nice. RP2040. Huge RP2040 lover right here. Love RP2040. Have you tried Bitwielder? Have you tried MicroPython out at all? I have an STM32, something. Yeah, I tried it, but I stuck to C++, and it's also my main program language. Yeah, it's awesome. MicroPython is very cool. It's still definitely new, but some of the stuff you can do is just like so powerful, or just minimal rather. Just in terms of like speed. Yeah, I tried it, but I stuck to... Yeah, so, but if you use C++ all the time, it would make sense why you're sticking with that. That would make sense. Is there a way to just download all of these? Following library files are also available. Okay, so what we do is you clone this. KiCad libraries. KiCad packages 3D. So what you do is you just clone these and then you update. You reference it in the editor. That makes sense. Okay, so let's clone these, I guess. Do symbols first. Code. Clone with SSH. I wonder why KiCad switched to... Actually, I bet I'm going to have this in here. Alright, here's the stuff. I have carbon D4, carbon V3, carbon S2, magma splash, jade pebble, marble pico, and a few jade N+1. What are the bit wielder? What are those? Are they all like dev boards? Good symbol. Okay, here we go. Yeah, all from Ground Studio. Cool. Alright, I got they all love them. They always assume USB chip. They're all USB-C. Damn. Alright, I got a BRB. I will be... Be right back. This is video of crabs. BRB.
I'm gonna take it step by step. There is some kind of poison and disorder. Going step by step, so I'm gonna break on past the border. Going step by step, it feels like there's something in the air.
I'm back. My bad. My bad. My bad. My bad. Did you enjoy the crabs? Look at these crabs. All right, so cool crabs. Yeah, bro. So let's Git clone. Yes. Huh? We're gonna do the symbols. We're gonna do the packages 3D. Never eaten crabs. I don't even, those are fiddler crabs. You don't really eat those. You do eat a bunch of other crabs up here. I'm in New England area, so we're very familiar with eating crabs, but not those guys. Those are cool guys. They're very small too, so they wouldn't be very good. You have to eat a lot of them. You should try crab. It's very sweet and delicate. It's really good. I'm an electronics engineer, not a crab scientist. Well, want to be an electronics engineer. Yes. It's a good point. Wow, this 3D repo is huge. Which makes sense. It is. That's probably. Let's see. Why did KiCad switch to GitLab? GitLab has more features for interest for project management. Interesting. That's good to know. Still got to get through college. Are you in college right now? Good for you, bro. This repo is big. I wish last year high school. Nice. Congrats on almost being done. Yeah, I actually went to school for electrical engineering, but or electrical and computer engineering, but then got into software after that. So I do software full time. Keep myself busy. I started a YouTube channel. Bro, what's your channel? Low effort electronics. Oh, I love it. Nice, dude. I hit you with the sub, beast. I'm gonna check this out later. Low effort electronics. I love it. Nice, dude. I wouldn't expect it to be a dumpster fire. Bro, just the fact that you're doing anything is insane. It's beautiful. Nobody does anything. Did I do the footprints repo? KiCad packages 3D KiCad sample. Now I need footprints, and then we're good. Hold on, one doing vid a week. Not too much, not too little. I love it. I love it. Alright, so now we gotta add... Close all this crap. We're gonna do... Manage symbol libraries. We're just gonna call this GitLab KiCad GitLab symbol. I don't know if this is the right way to do it. Funnily enough, my biggest issue right now is my goddamn nails. It's very funny.
The people come together. Makes it feel good.
Oh, I want all of these.
No destroying. It's the music.
Of course. So it's not gonna let me import all of these. Unless... Alright, let me... So what is in here? Okay, symbols. Rat. Beagle. MCU. Alright, let's search in the GitLab. Huh. Okay, so I have this. That's really annoying. BeagleBone KiCad symbol.
Drifting off to search for something new. I don't know if I'll be coming soon. I'll be sailing. You've been waiting. Feeling lonely. Don't erase me. Please don't always focus on my flaws.
And
Always say what I've been doing wrong. The seas change.
man, I wish I could go back to Linux, but the few games I'm playing with my friends are not working that great on Linux.
You keep drifting.
Yeah, you could get... I have a couple computers at this point. I do all the development stuff on Linux, and then pretty much games only on Windows.
Used to walk around so terrified. Now I feel like I am more alive. Deep inside me, don't deny me. Keep it clear, babe.
No.
I can feel these reasons ain't enough. What's the point of
Nah, I don't want the full clone. I just want the cape. Snap EDA.
Mathematic waiting, elevation lonely, cinematic face me, problematic hold you, too much static inside me, elevation not me, cinematic clear babe, elevation. Now it's time to take this final ride, trying to free you from the state of mind, need some freedom.
KiCad templates. What is this templates thing? Okay, wait a sec. Hold up. Hold the fort. New. Okay, they might have done it like that. New from template. Template selector. An empty folder. Template right here. Refresh. Okay, maybe KiCad templates. Oh, BeagleBone Black Cape. This is it. This is it. Gong time. This is it. Where's my gong? What? Oh, gong's gone. What the fuck? Oh, there it is. Yeah, baby. So it's a template. So they switched it off of a part into a template. Last time I touched this, it was just a part. It's like a symbol you placed. Now it is a project. Which is interesting. So now we can clone this. Hit clone. And then we can do this. User templates. We can go documents. KiCad GitLab. KiCad templates. Open. What? No meta info? Oh, okay. So you gotta, okay. Can't just have the one folder. We gotta do projects, BeagleBone Black Cape. Please. Yes. All right, we're fucking chilling. Okay, I'm just gonna delete what I had. Bro, I know. We're fine though. This is life. This is life. We lock in. We lock in. This is life. Projects. I'm just gonna nuke the whole project that I have so far. And we are going to make a new folder. Open, rack, vent, save. Discard changes. Goodbye forever. And now this. What? More than one running. Lock in, lock in. What? It was created with a more recent version than you were running? Bruh! I'm on KiCad 7. What is... Current KiCad version. Dude, I'm getting absolutely... KiCad 8? Alright, I guess we're updating to KiCad 8. Oh my god. Okay, we're just gonna try it. Here's a quick fix. Yeah. Okay. Damn. Linux other. Yeah, there's a PPA. Yeah, this is gonna be a sick, bro. I'm trying to stuff from myself from nuking Windows, installing. Try a VirtualBox. Do a VM. That's what I do for my day job. Actually, I use a not VirtualBox, but like VirtualBox, like a hypervisor that like runs. This is like this box. This is a VM. Like the OS here is a VM, and then I have another whole ass VM for software development, and then I have a bunch. I just use a bunch of Linux VMs that I run on a Proxmox server, and then I access them remotely, and it's just way easier to work out of VMs. They're just as fast now in terms of like interacting with the OS and stuff, but then you can like create snapshots and backups, and it's easy to restore things when they go wrong. It's easy to like run your VM on multiple machines. Yeah, that's what I do. You can do whatever though. Try it, but I mean, you could rock a VM, and if you get a new computer, you can just migrate the VM to your new computer. You don't have to like worry about reinstalling all your gear. Fine, I'll do it. LOL. Yeah, try VirtualBox is really good. For a hypervisor, you get all the benefits of snapshots with VirtualBox, which is great for when you're doing development, just because you can easily like. No, I'm gonna use a hypervisor. I've used it before. I'm gonna use hypervisor. Yeah, nice. All right, ETA minute 40 seconds. Okay. So what was the error that I got? Actually, I'm just not gonna touch this while it's updating. If you're in the market for a new hypervisor, Proxmox is really good. Proxmox is really good. I've talked about it a couple times before on stream. Mm-hmm. I have relied on Proxmox for many important things throughout the years. Okay, I'm realizing yeah, I should not be touching this while this is updating. Yeah, so it's 7011. I think that yeah. Oh no, it didn't come with a template. With KiCad 6? Empty again. Interesting. Librarian is a hard. Calling them librarian is hard. Alright, we updated with it. Ugh, okay, so that just updated the... we gotta do the PPA. Right, I remember why I hated Linux, yeah. Because they can't get Fusion to work on it, yeah. More or less, I hate Autodesk. Well, you could do... keep Windows as your main OS, and then have your Linux VM. Or just have a hypervisor and then have a Windows VM and a Linux VM. But I don't know if I would play games inside of a VM. I'm sure you could. I'm sure people do. Of course people do. Import settings. Okay. We have KiCad 8. Whoa. What the fuck? Huh? What is this thing? Yes, this is the way. Bit wielder, that's a good idea. Serial I2C. Huh. Okay, templates, projects, BeagleBone Cape. Is there a README? No. Meta? Info? This project is finished for the PCB outline conforms to the Cape. Uh-huh. Due to the fact that official 3D library does not include long or second PM headers. Okay. So it's if you wanted to put the EEPROM with the necessary Beagle Black. Okay, this is good. This is good. This is what we want in your system. System reference manual. This is good. You want RTTRT. This is very good docs. This is kind of what I'm saying with the BeagleBomb. I feel like the docs. Oh, this is the boy. This is the guy from last time. I'm gonna keep doing this until I get used to FreeCAD 1.0. Yeah, how do you like FreeCAD? Yeah, so you don't need the EEPROM with this. Ain't no Solidworks Fusion. But when you get used to the quirks, it's very powerful. The new one's actually pretty nice. That's good to know. I bought a Solidworks license for 3,000 bucks. So I'm Mr. Solidworks. I'm Mr. Solidworks. Was I happy to pay the money? No. But is it fucking solid? Yes. Does it works? Yes. Alright, so you don't need this EEPROM thing. So we're just gonna go ahead and delete this.
And I remember this feeling. Now I can breathe easy. No need to feel sorry. We should move up, we should move on, 'cause there's no coming back.
Due to the way the pin numbers work on the BBB, the connectors are actually 2.45 mil pin headers with the 3D models overwritten. Okay. Where is my edge cuts layer? Edge cuts. Okay. Alright, let's look at this thing for a sec. I'm wanting to look at the board. I'm wanting to look at the board. So I see what they're doing with that cutout, because they're just trying to... Fuck. So I see what they're doing with the cutout, because this connector interacts there. But again, we got 3 MOSFETs, or we got 4 MOSFETs. We got a bunch of connectors. Kind of actually have a lot to put on this. We kind of have a bit to put on this. I think we should take this. I think we should maybe take this into Solidworks to think about how we want to lay the board out. Because I have those DC power jacks I want to use. I got these. And these. DC barrel jacks. Whoops. I have a part number for this one. Actually, let's plow on the electronics for a little bit here. So essentially, we're gonna have does this have better docs, this URL? One, two, three, four, five, six, seven, 8 USB ports. Any cape that utilizes pins on the expansion header is expected to notify software on the board by providing contents within the EEPROM connected to the IDC with an address. To work with other capes, you can make your address selectable between those values to avoid conflicts. It is also possible to provide through connectors such that other capes can also get connections to the cape header pins. There's an example of EEPROM contents of the weather cape if you visit. What the this is a fucking mess. Are there even a ton of capes? Man, I'm not doing any of this EEPROM stuff. Yes, your cape board without an EEPROM will work like a PCB with the BeagleBone Black. You just need to create a device tree overlay for manual configuration instead of automatic detection via EEPROM. This lets you control the cape's functionalities through the BeagleBone Black software, similar to how you'd... Can I just hard code it? I guess if you... Man, that's so weird. Like, are there... Are there like mad capes? Each hardware has different internal pin assignments. But the device tree overlay absorbs these differences. How? Yeah, so whoops. I really don't get this EEPROM thing. This is like okay, so this is if you are How to roll your own BeagleBone capes. Fucking archive.org, bro. This EEPROM contents is intended to support the software in the BeagleBone to configure itself, specifically the MUX pin status for the P8 and P9 connectors. Yeah, I'm not doing that. We're just gonna do it. Community Papermint Designs. papermintdesigns.com/community. Man, Papermint Designs is gone. Damn. What was this? This is cool. Hey, I've got it installed. Yo, thanks for hanging out, Beast Bitwielder. I'm gonna check out your YouTube channel when I hop off. Nice hanging out, bro. Enjoy your sleep. Enjoy the rest of your high school career. One more semester, you can do it. I'll gong you out, bro. Peace. Bro, this blog is fried. Okay, this is so endemic. Recently I figured out how to make this post. Methods, bone scripts, circuit picture images. This is like the whole BeagleBone experience. Which is a damn shame because these boards are cool. Yeah. Okay. So it's just saying. Okay, we're not gonna use any of this because it's just saying what is attached, but I don't really think we can just say no other capes or just be clear about. Yeah, we're just gonna say no other capes. Which is fine. Okay, so let's add. So this is NMOS. Q, Jesus, NMOS, GDS. This is their guy. Want 3 of these or 4 of these. I'm getting the data sheet over here. Okay, so that's the same. Alright. Place symbol ground. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. USB port, battery pins. Where are the battery pins? Built-in battery charging capability. Holy fuck. Wow, look at this. Let's watch this. Hyperfocus. Wait, I'm pausing my music. We gotta watch this. Project Hyperfocus. Is it possible?
Is it possible to supply BeagleBone with up to 60 volts?
Eh.
Check it out. We start with recommended 5 volts. So far everything looks good, the user LEDs are blinking, which means that the board is working fine. Let's stress it out a little bit and increase the voltage to 6 volts. Uh-oh, something bad happened, it's not blinking anymore. Maybe the voltage is still too low, let's try 12. Still nothing. 15? Nah. 18? Does it mean...
What is this guy doing, bro?
BeagleBone? Welcome to my channel. I'm Maciek and I'm glad you are here. I hope you will learn some electronics and programming which will help us shape the world into a better place to live. Let's make the future come now. Today I want to show you how to supply the BeagleBone with a non-standard voltage, even up to 60 volts. But for the beginning, let's answer the question, why would we need it at all? Originally, BeagleBone can be powered from two sources, using the 5 volts external power supply connected to the barrel jack connector, which is the recommended way, or using the USB socket, which is 5 volts as well. Usually, we want to interface with the external world. Let's assume that we want to connect and drive a DC motor. Because the board pins can provide a very limited current, we can't connect the motor directly. We need a motor controller that will be driven by the BeagleBone using the PWM channel, and then the motor controller will drive a DC motor. What's more, very often DC motors are driven by a voltage higher than 5 volts. It's going to use motors powered by 12 volts or higher. For example, e-bike motors are...
Yeah. Bro's gonna use a DC to DC converter.
We've known so far.
Let's speed him up.
If we want to build robots, we need two...
You smell that? What is that?
What?
Oh, fuck.
Is it possible to supply voltage higher than 5 volts? It's going to use motors powered by 12 volts or higher. For example, e-bike motors are usually powered using 36 or 48 volts. All the things we've known so far points that if we want to build robots, we need two separate power sources, which may be a little inconvenient. We need to eliminate one of them. If we get rid of the wired one, we also increase the robot range. So in this case, we have to use unsupported voltage. But how we can do this? At the beginning, let's check the BeagleBone power management. As we can see, the hot pin from the barrel jack is connected to the AC input of the TPS. What is TPS? It's located here on the board, but let's look into the datasheet. We reveal that it's a power management chip. It's capable of providing 2 amps and it's 20 volts tolerant. So there is a hope that my board is still working. So the BeagleBone can be powered directly from a power supply higher than 5 volts, but this is what we need. How can we do this? We need to convert the too high voltage into appropriate level. We have two options. The first one looks obvious. It's inexpensive and has low noise characteristics. However, it also has low efficiency, especially during higher input voltage is used, which means that we can't use it with a voltage such as one present on an e-bike battery. And here the DC-DC converter comes to the rescue. It has better efficiency and allows for the use of higher voltages, even those required to power strong big DC motors. Of course, like everything in the world, the device we want to use has its dark sides. In this case, it's the cost, noise, and a slightly more complicated circuit. Now, when we know that buck converter is the proper way, we need to choose one. This is a Texas Instruments LM2576HV. I'm not sponsored by them, but I like their products because of nice documentation and good quality. You can see two versions, the THD, and the second one is surface mounted. I choose the HV version, which probably stands for high voltage. It can handle over 60 volts, which will be suitable for my e-bike battery. With this device, I will be able to create, for example, a Linux-powered onboard computer for my e-bike. The converter provides 5 volts output, so we have perfect match to the BeagleBone power rail. We will need to design the surrounding circuit, which is not very complex, although it does require a quite big capacitor at the output to reduce switching noise. Let's put this knowledge all together. There is a signal called VDD 5 volts connected directly to the hot pin of the jack connector. After searching through the document, we can see that there are only 3 occurrences of this signal on the power supply and 2 additional occurrences on the P9 connector. This is the
Okay.
place where we should provide output from our DC converter.
So it's the VDD. So you put the DC to DC converter there. $7?
Now it's time to make some electronics. I'm using KiCad software, which is totally free, used and supported by CERN, and can be run on all available operating systems. It's simple, and if it's enough for Collider team, it should work for me as well. What's great, it includes ready-made templates that we can use. Take a look. There are Arduino and Raspberry Pi templates too, but what we want is BeagleBone Black. Now we are set to go. Let's draw the diagram. So this is the main part, which looks quite similar to the one presented in the converter documentation. On the right side, you can see the plus 5 volts signal, which is VDD_5 volts from the datasheet. Zoom it out a little bit and look at this. It's exposed on the P9 header, in the same place like in the datasheet. I've added some extra features. A high current pass-through connectors, which allow for connection of power-hungry devices like electric motors, as well as additional connectors providing 3.3 and a 5 volts supply. Now it's time to make PCB. At the end, it should look like this. Production of PCB is not expensive nowadays. For a couple of dollars, anyone can produce their own board. This is the most exciting moment when the idea from your head becomes a physical device that can be touched. I've used both SMD and THD devices in this project. Now we will use the hot plate to melt the tin and solder elements to the board. We still need to solder the jack connector and the communication connectors. Unfortunately, for this purpose, we have to use a traditional soldering iron. This is what the final assembly device looks like. The screw connectors will be populated later. Now is the time for the final test. At the beginning, start with 5 volts as before and increase it until my power supply reaches its limit. It won't go any further, but look at this. The BeagleBone is being supplied with over 30 volts. If the DC converter manufacturer's datasheet is not lying, it should be able to handle almost twice the current voltage. Now this device can be used in several projects. I hope this material was helpful. You can access this project.
Look at the size of that cat.
Is it possible to supply BeagleBone with up to 60?
Okay, so turn my music back on. VDD 5 volts. It is this pin. So this net EDD5V. So there's going to be an input voltage of 12 volts. So let's start placing barrel connectors. Place, add symbol. So gonna have J1. This is gonna give us 12 volts in. There's gonna be some DC to DC converter here, which I haven't done yet. This is going to be some DC to DC block, but we're going to get on the other end of this, we're going to get this 12 volts. gonna flip this. Mirror vertically? No, mirror horizontally. Attributes, transform, boom. Okay, so this is gonna be so these go off to the different modules. Okay, I'm gonna move. This flow is a little better left to right, input to output. One, two, put it all over here. Nice. So because these are NMOS devices, they affect the load by manipulating its path to ground. So we wire up the negative terminal. We're gonna do 1, 2, this. Let's move this so it clears the name of the part. And then we got screw terminal. These are the red, white, and black connectors. Which I need to come up with crimping connectors for.
You can't stop. We're gonna celebrate one more time. One more time. One more time. A celebration. You know we're gonna do it right tonight. Hey, just feel it. Music's got me feeling the need. Yeah. Come on. All right. We're gonna celebrate one more time. Celebrate and dance so free. Music's got me feeling so free. Celebrate and dance so free.
One more time, music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time, music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time, music's got me feeling so free. We're gonna celebrate.
So it is
One more time, music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time, music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time, it's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time, music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time, music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time, music's got me feeling so free. We're gonna celebrate. One more time.
so the pin out here. So these are going to be for the. I'm going to label this. This is for the. These are for the standalone dummy modules.
Last night I had a dream about you. In this dream, I'm dancing right beside you. And it looked like everyone was having fun. The kind of feeling I waited so long.
I've done these.
Closer as we jam, the rhythm gets stronger. There's nothing wrong.
Yeah.
Little fun. We were dancing all night long. The time is right to put my arms around you. You're feeling right. You wrap your arms around too. But suddenly, I feel the shining sun. Before I knew it, this dream was all gone. Oh, I don't know what to do about this dream and you. I wish this dream comes true.
So we may want to do low pass filters here.
About this dream and you. We'll make this dream come true.
This would be resistor. Middle is ground. That's annoying. It's not that bad. So we're gonna want basically. So this is another circuit I've done that has is basically a fan driver, and I had luck doing a hardware low pass filter. So the output of the fan, the tachometer, the way you talk to the tachometer, so internally that tachometer, it has like a pull down, or like, yeah, it has a pull down. So whenever it pulses, whenever it twice per rotation, it pulls the tachometer pin to ground. So you have your, in this case, it'll probably be, let's do the pull up first. Place, add symbol, R, this guy, R. So what you do, so this, the third pin here is tachometer. And we're probably never gonna use. Oh yeah, PCB layout time. Fresh fish sandwich in the motherfucking building.
Show me your moves.
Fresh fish sandwich. You're an exceptional sandwich. Is there TF2 heavy sandwich sound effects? Wait, fresh fish sandwich. We might have to.
Work it, make it, do it, makes us.
Does he say sandwich? Oh, I got it on fast mode. Fuck. Oh no, I'm gonna have a seizure.
Did you listen? Just, oh god! Oh my god! Oh my god! Oh my god!
Is there a sandwich?
Ah, so filling. Moist and delicious. Sandwich make me strong.
Yo.
Full of sandwich, and I am coming for you. Sandwich and I are coming for you. Don't run. It's just ham. Bologna is perfect fuel for killing tiny cowards. Sandwich, sandwich. Me and my sandwich. What was that sandwich? Killed them all? Good idea! Look at you, tiny, itty-bitty man running from sandwich! You are a loose cannon, sandwich, but you are a damn good cop! Sandwich and me going to beat your ass! Kill them all! Run from the sandwich! Bologna!
I love this game so much. Oh my god. TF2 spy, killing spree, no, give me heavy taunt. Ugh. I need to get, wait, let me look for soundboard. What was it? Sound buttons. Sandwich.
Nom, 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 nom. Nom, 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 nom.
This might be your sound effect. The TF2 sandwich. This website is amazing. TF2, no, what? You're right, I am distracted. Oh, I fucked my playlist position. I was on stronger, I think. I'm adding the sandwich. Downloaded. Boom. Man who said bye on video calls. It's the price you pay for free soundboard effects. Okay, where do I actually keep the soundboard files? Where did I put this? Yes, found it. Projects, soundboard. We're gonna make a new tab. Chat. Fresh fish sandwich. You get. All right, reload. Add tab. Chat. Bang. Bang. Failed to play? What? Okay, so that's not working. Huh, what does it want to be?
It is happening again.
Yo, did he just walk up slowly and down smash?
I got the best soundboard in the motherfucking game. Okay, well, let's go look elsewhere if that file didn't work. Instant sound effect button. We got it. We got it. That's your sound effect. It's TF2 heavy eating sandwich. All right, we kind of got to lock back in here. All right, so yeah, internally the fan pulls down the high voltage. So these are all 12 volts. And this middle one is our source, is the drain. So it goes like this. And then this is tachometer output. Which I literally have no plans to use. Okay, this is kind of big. Put this over here. I'm gonna delete this for now. And let's duplicate this circuit a few times.
What's going on? Could this be my understanding? It's not your fault, I was being too demanding. I must admit, it's my pride that made me distant. All because I hope that you'd be someone different. There's not much I know about you. Fear will always make you blind. But the answer is in clear view. It's amazing what you'll find face to face.
Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 40, 50, 60, 70, 80, 90, 21, 22, 45, 29.
I turned away, cause I thought you were the problem. Tried to forget until I hit the bottom. But when I faced you in my blank confusion, I realized you weren't wrong, it was a mere illusion. It really didn't make sense just to leave this unresolved. It's not hard to go the distance when you finally get involved face to face.
Maybe if I I'm like, how do I make the drawing better? This drawing sucks. You gotta really thread the needle with the signal here. Ooh.
It really didn't make sense just to leave this unresolved. It's not hard to go the distance.
Honestly, bros.
Get involved face to face.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 2, 8, 4, 5, 6, 7, 28, 29, 30. Let's just do 30. Let's space them out 30 points apart. 7, 8, 9, 10, 11, 12. 14, 15, 16, 17, 18, 19.
Much too long. I feel it coming on. The feeling's
Okay.
getting strong. It's been much too long. I feel it coming on. The feelings in my bones. It's been much too long. I feel it coming on. The feeling's getting strong.
Is that right?
Been much too long. I feel it coming on. The feelings in my bones. Too long. Can you feel it? Too long. Can you feel it?
That's right.
Too long. Can you feel it? Too long. Can you feel it? Yeah. 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 At last, the long wait is over. The weight is off my shoulders. I'm taking all control, yeah. My mind is set so free. I'm where I want to be to get the best of me. Too long. Can you feel it? 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 I see you feel the way I do. The feeling so true. The good feelings coming through. My mind is set so free. I'm where I want to be to get the best of me. Too long. Can you feel it? Too long. Can you feel it? Too long. Can you feel it? Too long. Can you feel it?
So we can move this in quite a bit.
It's been much too long. I feel it coming on. The feeling's getting strong. It's been much too long. I feel it coming on. The feelings in my bones. It's been much too long. I feel it coming on. The feeling's getting strong. It's been much too long. I feel it coming on. The feelings in my bones. Too long. Can you feel it? 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 At last, the long wait is over. The weight is off my shoulders. I'm taking all control, yeah. My mind is set so free. I'm where I want to be to get the best of me. Too long. Can you feel it? Too long.
God, this is ugly. It's okay.
Can you feel
Ugly is fine. It's actually not that bad. It's not actually that bad.
Can you feel it? Too long. 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 Can you feel it?
Autoplace fields? Huh. That's kind of lit. Never seen that before. Can move all this down 2 spots now. I like this autoplace fields thing. I've never noticed that before. Okay. And we fit it. Honestly, we gotta change the page size. Page settings. A5? A5 is smaller. A3? Nice. Big ass schematic, dude. No. Wish I could make these a group. I guess it's not that hard to move it all around like this. P9 is kind of gonna be what we're using. I feel can we fit these two like this? You gotta get the, yeah, we can easy this down here. We got the thermistor dealies. Maybe? Dang. So what did the... Yeah. So it's one side of the connector is pulled up, the other side of the connector is pulled down because it's a voltage divider. Makes a lot of sense. So then we need So we got 7 analog inputs. We know we want at least 2 temperature sensors. We might as well do 4. I think we should do 4. And we also might as well I've been thinking about other stuff I want to potentially do with the rack in terms of integrating hardware. I think it could be good to also add like fan or LED headers. And we already have the PWM control pretty well established at this point. So we could do, I have like boxes. Wait, let me go show this. Let me go show this off. Oh, I got the wrong thing over there. Whoops. Let me go grab my box of LEDs and show you what I'm thinking. The box. The box. The box. I'm thinking about these guys. So these are, I've had these forever. See the plastic is yellowing. But these are out of focus for one. But these are RGB LEDs that are not addressable. They're just 12 volt DC. And I've had these, oh my god, look at this. They're so damaged from all the light that they've passed through them, which is so funny. But they're great, and I've got them, and I've been thinking about potentially doing lighting inside the rack with them. So I think I'll do a pin header for these as well. Oh my god, it's the man himself. Donna Just Gold is back. Justin is back. Where's my soundboard? Dude, I need physical soundboard yesterday.
Happy feet. One more combo. That ain't Falco. Yes.
He's back. What's up, bro? Yeah, damn. We're getting into the PCB design today. I forget the pinout of these RGB LEDs though. I did write it up on the blog though a long time ago. Yeah, this is an old video, boys.
The project I've been working on over the last couple of weeks. Turn them on and off on the box. They're the brightness of each of the strands of the LED. So I'll just go through and mess with that. You can see you can mix the color, so red, green, blue.
Yeah, they're active low.
Kind of comes with purple on the camera, but I'll make it white. So you can use like analog pots to control on a phone or on a computer. Buck boost.
This old project.
Steps down the 12
Old but gold.
LEDs.
What year is this? 7 years ago.
To 5 volts for the rest of the electronics. And that's pretty much it. There'll be a blog post in the description with the stuff, but
I'm trying to decipher what the fuck is going on here. Whoa, whoops. Oh, okay, so I see. Yeah, so they're definitely active. Common cathode. No, common anode strips.
I want to 3D print an enclosure and like a
So let's also include... Oh my god, I'm on the wrong thing. I'm looking at this old project that uses these strips. This very old project.
In the final one, 12 volt power.
Yeah, so... Where's my hand out of the frame? So we got power supply that is tapped here, and then the 12 volt positive goes into here, and then you have the RGB for the negative. Okay, so we'll do... We could do... How many PWMs do we have? We need 8. No, we need 7 to do this. One, 2, 3, 4, 5, 6. That doesn't seem right, though. Okay. Extremely useful links. Ugh.
Man, I'm gutted. There's no atmosphere here.
Yeah, right. What is she mixing?
And look, no one's dancing.
You're right. So you wanna go back to mine?
Yeah, I've given up hope on this place.
Song is the best. Okay, BeagleBone has eight PWM pins. Where? Okay, they're here. 1, 2, 3, 4, 5, 6. God, this is so fucking annoying. Yeah, so there's only 6. All right, so this LED thing. Maybe not happening. All right, so we can't get at. So we'll do more analog inputs. I'm just gonna have them. I'm just gonna have. I'm just gonna do all temperature sensors, all 7 slots. So we're gonna do seven of these. Fuck it. One, 2, 3, 4. Nine, 10.
Eternal dance.
You're gonna want a global label on this. It is so dumb to have these be visible. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. One, two, so we're gonna do like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, we're starting to cook here. I guess I could. For the LEDs, I could short them together. Okay, let's start to think about seeing what all these guys look like. Actually, we want more global labels. Label. Then we want more global labels, actually. So I'm getting close here to a schematic. You'll notice that the values are not filled in for many of the components. And that's intentional. We know all the thermistors are going to be 10K pull downs. I think what I'll do is just have... Yeah, because if I do one more 3-pin, that's what I'll do. We'll do this. So I'm just gonna do, because there's 6 PWM outputs, and I'm just gonna put the remaining 2 on a screw terminal. Just to have them. Damn. Okay, this is a little annoying. We gotta move everything up. It's not that annoying. See what I'm going for here? This is just going to be like a general use PWM output pair. See, so we got fans. Hmm. Oh, I forgot about the fucking exhaust fans. Alright, so that's what these have to be. So these are for the exhaust fans. We have 2 exhaust fans. I forgot. exhaust. Okay, wait. I gotta go look to make sure that the MOSFET we were looking at has enough power. We gotta go back to research mode. Did I really not link the fucking part? Bro, I am stupid as shit. What is this? Alright, give me a sec. I'm looking back at my notes. Orders. This is the exhaust fan I came up with. It is massive. What? Consumes less power than the other one, so we're chilling. That's crazy. Consumes less power, so we can totally use those same MOSFETs. I think I want to have flyback diodes. Just in case. I don't really know what those fans are. I'm assuming they have some sort of smarts in them. But the less service I can do on this box, the better. Then I also want pull down resistors here. No, I just fucked the grid up. Grid. Okay. Ooh, that's annoying. 2, 3, wait. Mm-hmm. Getting a little tight here. Getting a little tight. Let's see if we can move this all down. Or up, rather. Okay, I haven't said a word in a while. I think it should probably be, we should probably be done. Let's make a Git repo for this. Projects. Open rack vent. Okay. Okay, chat, that is it. Until 2025. Thank you for everybody that's been rocking with me. Fresh fruit sandwich. Found Just Gold. Thank y'all. Gonna stream, continue to do the Tuesday thing. Project is getting there. But to be honest, I think we still got a long ways to go. So yeah, probably a bunch more broadcasts. Okay. Last gong of the years. Last gongs of the year. Peace.